Hello. In this session, we're going to be going over how to solve a heterogeneous differential equation. And what that is going to be our solution. Our general solution is going to be equal to our homogeneous solution plus our trial particular solution. All right, so what does this mean? Say, for example, we had this problem, right? Y double prime plus 4y prime minus 2y equals 2x squared minus 2x plus 6, right? So our heterogeneous solution is going to be as if we took our left side and set it equal to 0, and we solve it as if that were the case. And our particular solution, yp, is going to be looking more at the right side of our equation, right? Taking our what's known as g of x and turning that into a particular solution for this problem. Okay, so our first step, let's go ahead and solve for YH, our homogeneous solution. So let's set a new page right here. Y double prime plus 4y prime minus 2y equal to 0. Okay. Let's do a popular substitution. So let's let y equals e to the mx, right? And if we substitute this equation in for every y, we'll get m squared plus 4m minus 2 equal to 0, right? Now we got to solve for m, right, using our quadratic formula. So we'll get m equals -4 plus or minus the square root of b squared, so 16, minus 4ac, so that's going to be plus 8, over 2, right? So we simplify this, we'll get m to be -2 plus the square root of 6, and we'll get -2 minus the square root of 6, right? So our homogeneous solution, right, we'll write it over here, y homogeneous is equal to a constant times, right, going back to our substitution, e to the mx, so our first m is -2 plus square root of 6x, and then plus our other constant times e to the other mx, right, -2 minus the square root of 6. Okay, so now that's how we found our homogeneous solution. Now, right, we did this. Now we gotta look for our trial particular solution, okay? So let's go back to, let's write down our g of x. So g of x equals 2x squared minus 2x plus 6. How are we even going to come up with yp, right? There is a list of something called trial particular solutions. It's in your textbook under table 4.1. Like, you kind of print out a table that kind of looks like this. And it says that, okay, if g of x is in the form, if g of x has an x squared now, our trial particular solution is going to be ax squared plus bx plus c, right? And this is all about, we have to solve for a, b, and c, right, to get yp, okay? So we have yp. Thinking back to our equation where we had a y double prime, we had a y prime, and we had a y, right? This can correspond with y. So let's go ahead and find y prime of p, which is going to be 2ax plus b. And let's go ahead and find y double prime, which is just going to be simply 2a, right? Now that we have this is our left side of our differential equation, right? Our left side, we can set it equal to our right side, right? And plug in our different y particulars for that. So we'll get our y double prime particular, 2a, plus our y, 4 times our y prime. So that's going to be 8ax plus 4b minus 2 times our regular yp, right? So minus 2ax squared minus 2bx minus 2c, and this is all equal to our g of x, which was 2x squared minus 2x plus 6. Okay. Now to solve for a, b, and c, we have to set up a system of equations, right? So what is a way that we could organize to create 3 different equations? We could have all the x squareds equal to each other, all the x's equal to each other, and all the constants, right? So let's do our x squareds first. So on the left side, we only have this term, so minus 2a equals 2. Okay. Now let's do all the regular x's. So we have, let me erase this up here. We have this term with an x in it, this term with an x in it, and this term. Okay, so we'll get 8a minus 2b equals -2. Okay. Finally, we can do our constants to get our third equation. We have a constant here, constant here, constant here, and a constant here. Okay, so 2a plus 4b minus 2c equals 6, right? And we can kind of go down the line with this, solving for our different variables. So here we'll get, right, we solve for a, it's going to be -1. Plug that into the next equation, and we'll get b equals -3. Plug both of these into the bottom equation, and we'll get c equals -10. Right, so our final yp is going to be, remember, it's our ax squared plus bx plus c. So -x squared plus bx plus c, right? But they're all negative. So we have yp, we have yh. We can now find yg, right? Because yg is yh plus yp. So yg equals c1 e to the -2 plus square root of 6x plus c2 e to the -2 minus the square root of 6x, and then plus our y particular, which we said was -x squared minus 3x minus 10, right? Where this section is our y of h, and this section is our y of p. Okay, so this is going to be our final answer. And that process is pretty much the same for a lot of the heterogeneous differential equations.